Welcome, everyone. My name is Ming Hu. For those of you who do not know me or haven't met me before, I am a professor in the School of Architecture. I am Associate Dean for Research Scholarship and Creative Work. It's a long title. It is my pleasure to introduce tonight's speaker, Professor Michelle Addington. I also see we have friends across the campus to join tonight's lecture. Professor Michelle Addington was the former dean of the University of Texas at Austin School of Architecture. Formerly, she served as Jared Hines Chair in Sustainable Architecture Design at the Yale University School of Architecture and was jointly appointed as a professor at the Yale University School of Forestry and Environmental Studies. Prior to teaching at Yale, she taught at Harvard University, GSD, Graduate School of Design, the Technical University of Munich, Temple University, and Philadelphia University. Originally, very interesting, originally educated as a mechanical and nuclear engineer, Michelle Addington, Professor Addington, worked for several years as engineer at the NASA Space Flight Center and for DuPont company before she studied architecture. So we successfully transfer a convert engineer to architecture. Her teaching, research, and professional work span across those disciplines with the overarching objective of determining strategic intersection between the optimal domain of physical phenomenon with the practical domain of spatial, geopolitical, economic, and cultural system. Her books, chapters, essays, journal papers, and articles address topics ranging from fluid mechanics to the history of technology to smart materials. So she is my personal role model, and she is one of the pioneers in sustainable design in architecture and engineering. So please join me welcoming Professor Michelle Addington.
Actually, Ming is my role model. I've known Ming now, I don't know, at least 10 years, if not longer. Probably the most brilliant researcher working in the field today. I would give anything to have studied with you. And I'm going to give anything if I can do some research with you because you're really incredible. I do want to thank you for inviting me. I've never been to Indiana before, so I'm discovering a whole lot about Indiana, about South Bend, but most importantly about Notre Dame, which blows me away. I've had an incredible day. Everybody I have met has been so intriguing, so fascinating. And the students, you all are amazing. I have never enjoyed a lunch more with students than I enjoyed today. And let me just say, as a dean and a professor for such a long period of time, I've had to sit through an awful lot of lunches and snacks with students. This was an amazing group of students. And I also had a marvelous afternoon learning what your dean is planning. And I'll tell you more about that at some point in time. It was just fascinating to hear what's going to be happening here, what has happened here. So I'm just thrilled to be here. Let me start off with a rather sobering story. This happened right before the pandemic. I was invited to a closed summit on sustainability organized by world leaders at architecture firms and sustainability consultants. Wanted to talk about what we should be doing as a profession. They only invited 2 academics to participate in this symposium. Interestingly, we're also the only 2 women who were at this symposium, kind of a sign of the times. What caught me by surprise at the beginning of this symposium, and understand it was closed, which meant that we could really talk about things that mattered without having an audience that we had to posture to or sort of convince in a certain way. But really caught me by surprise at the beginning is the first principal got up to the one who convened everyone, kicked it off by saying that We all in the room have to agree that no client should ever notice sustainability, we should not have any impact on the way that we design. And it should be something that they should never experience the slightest change in how they experience a building. You know, if we do sustainability right, we put in the right things, you know, they are going to be untouched, and we get to design the way we want to design. I was sort of thinking, like, you know, I'm not quite sure I'm on board with that approach, but that's how the summit started. And what really sort of disappointed me about the summit is it very quickly shifted to what other people were doing wrong. Most particularly at that time, what the President of the United States was not doing in terms of absolutely foregrounding and supporting sustainability. So at the end of this intense summit, what did they come up with but a letter, a one-paragraph letter to then President Trump, telling him that he needed to sign the Paris Accord, and it was going to be signed again by, you know, a handful of firm leaders and sustainability consultants from around the world, and they thought this would be really impactful. I was the only one in the room who wouldn't sign. And I didn't sign because I didn't think that we should be involved with the Paris Accords. I didn't sign because I thought, here we're meant to lead the profession. This is not leading the profession. You know, when we've decided that somebody else is responsible and we're not taking our full responsibility for making a difference, I can't be a part of this. And so, you know, how did we end up here? How could we have spent so many years working on this for a surprisingly important group of people to decide that sustainability is something that should be invisible? It's some things that you specify, but reality, nothing should have to change. Nothing should impede our progress toward doing what we want to do. And I think, you know, there's some in your room who probably, wait a second, I'm not really good at multitasking, which involves multiple hands and a voice. So bear with me while I sort of don't use the keyboard, which I'm going to be tempted to use. Probably remember this era or this generation, you know, back in the 60s and 70s, when this is what, you know, the early proponents of sustainability felt like. It was very much about form, being formally determined within this, much reviled by, you know, many in the profession, and, you know, something rightfully so. Part of it is because of the being reviled had to do very much with the form that people were seeing. But the reality is that the science wasn't particularly good on many of these projects either. And that was sort of a big problem with it. But the backlash to it, the reaction to this was actually way outside from the actual penetration of this. There weren't that many examples of this for the architecture profession to react so strongly to it that it did at that time. But it is what led us down this path that, you know, instead of something that's formally determined, it was all going to be about technologies that we specify, certain things like that. And so we began to sort of shift away from it being form, and we start moving it to things that we choose, things that we specify within that. And that's where we are today. We're still very technology driven within this in terms of a specification, very little about how we think about our buildings, very little about how we think about our cities, or what we're rethinking, what we're redesigning within this. So how do we end up here? Well, there's going to be two watershed moments that set the stage for almost everything that is happening in sustainability in this country and much of the world. And the first was the publication in 1962 of Rachel Carson's Silent Spring. She was a marine biologist working with the something to do with wildlife service. And she began to notice the impacts of DDT, not just on certain types of species, but the fact that these impacts were rippling through the food chain, so impacting much more than just sort of like the species for the first contact within that. This book completely changed the way people in this country and much of the world began to think about environmental consequences. And interestingly, this book is what led directly to the formation of the Environmental Protection Agency. That came from people who were sort of proponents and talking about what happened in terms of the contamination caused by DDT. The other one, and some of you in this room will remember it, I certainly do, 1973 oil embargo. The oil embargo changed overnight the way that we lived in this country. The most sort of dramatic part of it, of course, was the shortage of gasoline that took place. But the other part that happened very quickly within this was a series of very fast policy decisions, doing things like actually changing the way that we operated buildings. Everyone in here has probably taken an environmental systems class. You've studied things like constant air volume and variable air volume. We were constant air volume systems until this happened. After that, we switched to variable air volume systems. And a lot of the problems we have with sick building syndrome emerge from that time period, but that's something that comes later on that. Again, a backlash eventually. Oh, by the way, speed limits went down to 55. As somebody who drove a Mustang at 85, it was very difficult for me. But on the other hand, I didn't have any gas for it, so it really didn't matter that much at that point. But this too was a watershed moment. It shook up our government, and this is when the Department of Energy was formed as a result of that. So you think about this, the two main agencies in this country dealing with one, the environment, and the other one with energy, came out of these sort of two watershed moments. So it was just a few years after this that the UN decided it was time to start putting together a more comprehensive, a more coherent way to address these problems. And so in 1983, the Director General asked Gro Harlem Brundtland, she was the Prime Minister of Norway, to chair a new commission to formulate a global agenda for change. That commission was the World Commission on Environment and Development. And this was their objective. It was, first of all, to begin to understand collectively questions of environment and development as opposed to sort of treating them as something separate. It was to begin to build international cooperation, particularly through treaties and policy. And it was also had a mission to deal with education, sort of raising the level of knowledge throughout the world as to these issues. These were issues that they put forward on this as sort of the things they needed to be thinking about. And this is a stunning list of things environmentally that they were concerned about at that time, but they were equally concerned with developmental issues that affected particularly the poorest segment of society. You can see on here it was about housing, literacy, it was about malnourishment. All of those things were in there. And so part of the reason that this commission formed was to sort of like deal with this as a collective series of actions as opposed to sort of piecemealed in terms of working on one thing, working on another thing within that. While they were meeting, this is the stuff that happened in the world. They met for 900 days. And we see some of the world's most significant environmental disasters took place, particularly the incident in Bhopal as well as Chernobyl took place during this time frame. And so if we think about this particular commission, by the way, it's nicknamed the Brundtland Commission after Gro Harlem Brundtland. 1983, they were convened. 1987, their report released. These are all the things that they talked about, and these are all the things that began to come out of this commission. The first thing, Intergovernmental Panel on Climate Change is formed. The next thing, the Montreal Protocol went into effect. The Montreal Protocol dealt with chlorinated fluorocarbons, their impact on the ozone hole. I would say that we can probably look back in the history. The Montreal Protocol was the most successful international treaty addressing a critical environmental problem for us. The United Nations Framework Convention on Climate Change, which basically is sort of sets up a treaty or sort of a set of parameters for how we were to discuss dealing with climate change, was established. The first COP, Conference of Parties, is what that's short for. When we hear every single year about climate negotiations, that's a COP meeting taking place. The first one happened, again, all this proposed in the Commission report. The Kyoto Protocol, again, speculated on, came out of this part where we saw our first like clear targets that we were looking for in terms of managing temperature. What we know now is the UN Sustainable Development Goals came from this. The Kyoto Protocol took effect on 2005. US, by the way, was not a signatory to the Kyoto Protocol. They were a signatory to the Montreal Protocol. And then 2015, the Paris Agreement signed on this. So that's all that we saw, not all, I'm sorry, but that's sort of a kind of brief survey of what happened from this fantastic, unbelievable committee that convened, what they pulled together, what they spurred, what they created worldwide, what they got in place worldwide, and what they haven't been effective in worldwide came out of that. But probably the most extraordinary international set of actions that we've ever seen on any subject. Now, for the architecture profession, they didn't pick up on a lot of the stuff that was happening. This is the one thing the architecture profession really liked out of the report, was this statement on sustainability. The difference is that the architecture profession, much of the design profession, actually much of the US, for a matter of fact, defined this statement, what sustainable development meant, very, very differently than Gro Harlan Brundtland and her team did. So their definition, what architecture picked up from this, is that it's sort of like preserving my future, preserving the future for my children, preserving the future for my neighborhood, my community, but sort of a very insular idea about what sort of defined preserving or sort of meeting the needs of the future. That's not what Brundtland meant at all. This is what they meant. They meant that there was this sort of intractable problem between economies that were developing and the most affluent economies in the world, that for the most affluent economies, their environmental problems, or what they caused environmentally, were distant from them spatially, so it never affected them personally, but also distant from them temporally, far off in the future. They were insulated from those problems. Those in the lowest segments, you know, they're living with cook stoves that burn carbon. They were the ones that were directly affected both spatially and instantly affected by that. And for what has traditionally been so, for economies to move forward up that ladder basically means shifting to coal. And because they're shifting to coal, one had to accept the fact that in order for these economies to move forward, they were going to become greater polluters, even greater polluters than they were. And so for Brundtland and her team, the idea here was how those of us in the affluent and the wealthier parts of the world were going to have to sort of make sacrifices in order to allow the rest of the world to begin to catch up. And those sacrifices were going to be so that the rest of the world would actually have to go through that cycle. So her idea, or their idea, of sustainability and preserving for the future was not about preserving our future per se, such that we can continue to waste as much as we wanted to, but it was about sort of like ensuring that those who did not have actually had a future. we missed all of that. And so many of our goals on sustainability, particularly when we think, is this a sustainable house? This is a sustainable project, completely missed the idea that sustainability was never about an isolated thing and its future, or an isolated group of people and their future. It really was about finding this kind of support throughout the world. So 20 years after the commission came out, I thought it would be a good time to take a pause and see how it had impacted the field of architecture. So I convened a symposium at Yale. This is the poster from the symposium. And the idea was, as much as we had been talking about sustainability, I saw very little evidence that we were making a difference. And so this was the charge that I had on it, that it was timely to ask this. I decided that who better to come and be the keynote speaker. So I found Gro Harlem Brundtland. So I brought her in from Norway to be the keynote speaker. This was at Yale, and I don't know how many of you know Robert A.M. Stern, who's a dear friend of mine, and he was the dean who lured me there from Harvard. And when I told him I was going to bring Gro Harlem Brundtland, he goes, "Prime Minister, sounds dull." And then he was very alarmed when he found out she wasn't going to have slides. And I will say that at the end of her talk, he said he'd never heard a more riveting speaker on that. So I'm very gratified by it. But the idea of this symposium was to bring in people that we didn't normally talk to. So I brought in neurobiologists, I brought in people from the Defense Department, a whole wide array of people who saw things in a very different kind of way. And I had really hoped from this symposium that people would start to share ideas, talk about this in a way that we could begin to sort of envision something different for the future. And then I capped it at the end by inviting the most well-known sustainability architects to sit on a panel. And what fascinated me is we heard amazing things, particularly from the neurobiologist who explained how vision worked, as well as from an environmental psychologist. We heard amazing things that were very provocative, fascinating, great opportunities for us to work on. But when we got to the last panel, and I'm hoping no one can read the names on this, I think I blurred them enough so you couldn't quite read the last names on this. What did they feel like we needed to do? More building codes. So we just need more building codes, and we need more people to hire us, because we already know what we need to do. We just need people to hire us on that. So they'd kind of missed the whole sort of incredible array of things that happened during this symposium. Instead, it was really about, this is my job, this is what I do, I know how to do it. Nothing really needs to change here. Other people need to change. So this is Gro, at the symposium. And, at the end of her talk, and it was sobering. Unquestionably, it was sobering. The audience was just filled with questions. And there was an audience from not only across the university, but many people from New York came out to hear this as well. And most of the questions were things like, well, what if, we built more nuclear plants? What if we geoengineered the upper atmosphere? We could solve all that. And yes, there was also the ones like, what if we got more building codes? That showed up as well. And she got exasperated after a certain point. And what she said, it was basically, this was a version she wrote later, but what she said at this point was that sustainability was not something you could achieve. What it was a series of difficult questions with answers that weren't clear. It says, so what we had to do is actually keep trying. We had to keep asking those questions. We had to keep testing. We had to keep failing. So, but with each one of those, we're going to learn something a little bit more, and we're going to do a little bit more good. That's what we hope for from sustainability. I'd say that made most of the audience very unhappy, because they wanted a heroic solution. They wanted a singular answer, a thing that we could all agree on. We could do, particularly not what we could do, somebody else was going to do, sort of work that out. They weren't sort of really ready for the most important figure in the world on this to say that this was a series of difficult steps and a difficult set of actions. So what actual progress have we made now that it's been 40 years since this convention began its work? So I apologize, I'm going to show some of these graphs. So we've gone way over what we said for the Kyoto Protocol. And while many people will look at this graph and they realize, North America is that sort of big swath of baby blue, kind of running through the middle of this. Europe, we can see where Europe is down there as well. They say, well, hey, a lot of us have done really well. Like we haven't gotten any worse. And, we can blame China and India, for this raise. Well, it's missing a key piece of this, and all the patting on the back for saying we've actually been doing well, missing a huge piece that's problematic on that. And this is it. It's called fuel mix. What's happened within particularly the electric industry is that natural gas has replaced coal. How many mechanical engineers in here? Yay, so you know what higher heating value is. Natural gas has a much higher heating value than does coal, which means that you get a lot more energy out of it than you do from burning coal. And so you're just swapping now to a fuel that's more efficient. So this is what happens within that. So all of the progress that we thought we were making in those affluent societies, we weren't making any progress. We were just purchasing different fuel. And this is really key within this because there's really no free lunch in any part of this. Yes, this is a better fuel to be using. It's a cleaner fuel to be using. But the fact that we've stayed flat tells us that we're now using more energy. So if we took it back to coal numbers and say, well, what if we only had coal available, we'd be on that same skyrocketing sort of increase there. People might look at this and say, hey, we just got to have more renewables. Well, the actual picture with renewables is that there's a big difference between renewable and carbon-free. Most of the renewables we have in this country are not carbon-free. That's going to be the biofuels, the wood, and the waste in there. And not only are they not carbon-free, but they're much worse than fuel oil, and many of them as bad as coal within that. So we haven't really found our salvation by making this switch within here. And we'll talk a little bit more about this later. I love this diagram. It's a Sankey diagram. And the thing that's interesting about this diagram is that every single purchase of a fuel material is on here and who's paying for it. And so if you were to look up here, this is the building section. And so you can see, of course, within that, the natural gas that's going to buildings, the fuel oil that's going to buildings, and of course, the electricity that's going to buildings in here, transportation, industrial, and then this monster, which is wasted energy in the electricity sector, and it's going to become a big player. So this is how we've been accounting ever since, interestingly enough, the oil embargo. So yes, it's a good, useful representation, but it has incredible limitations that are actually not very useful for us to work with. And so coming back to the oil embargo, what we have to remember is that the panic it caused in this country about who owned what, where were we buying, from whom were we buying our fuel oil, where are we buying our minerals, all of this spurred within this sort of an accounting to the moment of ownership and when cash changed hands. So ownership changed hands with cash. So this was all about where the transaction took place. If we look at this diagram, this is all about the cash transactions. Where the money changed hands for the minerals over here that were owned. So it's all about ownership and it's all about place of purchase. So what happens within this is that it doesn't include this operational energy in buildings up here. Oh, I'm doing all kinds of weird stuff with this. This operational energy in buildings doesn't include this. You can see how little of this is actually going to anything other than buildings. This is all us. It's just that the cash is played someplace else. And so it's accounted for someplace else. So it's left out of this accounting. You will find many sources that do find a way to bring it in, but the main accounting source keeps it completely separately. If you look at both, whether it's the International Energy Agency, you look at what the EIA in the US, they separate this sector out and talk. They'll might mention primary energy, which will include this. This is a massive amount that should be accounted for up here. Most of this should be accounted for up here. Transportation energy, yes, we are starting to pay a little bit of attention to transportation energy in terms of construction. So there's some life cycle analyses that do include that. But really, the lion's share, if we start to think about it, is also our responsibility, because the very way that we design our cities totally impacts the way that we think about transportation energy. How do we begin to sort of account for the decisions we're making in terms of building and how that results in this type of transportation infrastructure? And then industrial energy, the same thing. All of the embodied energy we put into our buildings gets counted for by industry. Again, that's where the money is paid directly for the fuel. We pay for the product, but we don't pay for the fuel on our end of it. And so again, we've got life cycle analyses and embodied energy analyses that are beginning to tell us about how we can account for that type of embodied energy. But how does that come into to take into account how we deal particularly with when we build out in an urban area? Because the infrastructure is us too. We don't have a good means of accounting for all of the infrastructure that goes to support that building. We're starting to see that an awful lot of this chart is our fault or our responsibility in order to deal with. And so one of the things that's really, really key for, none of these sectors actually deal with the electricity losses, but what they are good at, what they're very clear at, and what you particularly see here in the transportation, sorry, on this back up. You'll see in the transportation sector is that in places where it's a very straightforward use, a purchase to a direct conversion, we account very, very well for how an automobile, how a plane, how a train uses energy, because that's a straightforward conversion of that cash into motion within that. We do a terrible job of really accounting for any of these other sectors on it. So in 2010, the Secretary General, not the Secretary General, but I get all the titles mixed up, but the Director General, it depends which agency you're talking about, the Intergovernmental Panel on Climate Change, contacted me and asked me if I would pull together a session for the COP16 that took place in Cancun. We'd had a number of conversations about how all of these discussions that were taking place at these UN meetings every year were actually not talking about buildings at all, mostly because they thought buildings were kind of an insignificant player within this. Part of it is because of the poor accounting, but part of it is because they thought, buildings are easy. We really don't need to internationally sit here and talk about buildings. But we'd had a number of conversations and he became convinced that we needed to start talking about buildings. So he asked me to pull together a session, a side session to talk about this. And it was for this particular climate change conference. And this was the session I put together. And it turned out the idea of this session was to bring India and Germany together, primarily on this. The approach in Germany was very, very different than the approach in India at the time. And I thought this would be a great way of kind of like sitting on the table, talking together about what we could be learning from each other. When people realized that Rajendra Pachauri, who was the Director General of the Intergovernmental Panel on Climate Change, was going to be there, I suddenly had a flurry of different prime ministers and energy ministers from throughout the world who suddenly needed to be on the dais and speak as well. I will say the session itself was not great because everybody was saying that they knew how to do it, and people just needed to listen to them, and the different prime ministers were just wanted to talk about how great their country was doing. But it was something that, because I was doing that, I needed to read what every country was doing that I was bringing into this so that I could be prepared. So I did my homework and I read every document that existed at that time, nationally and internationally, on buildings and energy. And there was something that really struck me by surprise as I was reading all these documents, getting ready for this, high-powered session. It was the fact that there was a single statement that showed up in all of them. This was the statement. This comes from a US document, but that statement showed up. It showed up in India. It showed up in Germany. It showed up throughout in different languages, by the way. So translated, roughly the same statement. And I kept thinking, I don't know what they're talking about. I would like to know how we could overnight, reduce energy 30 by 50% with specific types of technologies or generation systems within that. So I did what any good researcher would do. I hope your librarian is here, although I don't think she is. Did what any good research would do is I did a paper trail on this. Because what fascinated me about all these documents, the majority of them never cited their source. It was just something like, this is what we know, this is what it is. I finally found the first citation of the source, and it took a long time to track it back because a lot of these things, and I discovered this about a lot of stuff that enters into our field in architecture that people feel very strongly about, but by the time you track down where it came from, it was a really bizarre statement in one really weird instance. Then you can't believe something becomes sort of accepted as fact when you do that. Well, this one, it took a long time to track it back, but it tracked back to a study of 12 houses in Southern California built at the same time using a particular set of technologies. So it goes from, and then moving forward from there, then, the next version of it, well, it wasn't 12 houses anymore. And then it wasn't Southern California anymore. And then it wasn't sort of like they were all built in a particular time. It suddenly becomes a worldwide number, it expanded from that. And everybody accepting that as fact. And, this is today. This is from the Department of Energy's site today. They're still repeating. And actually, I've tracked the Department of Energy. They've moved it up a little bit every year. So now this is the number that we're at on this. So this is part of the problem that we're dealing with. It's hard to get people in many fields to take what we're doing seriously. It's hard to get them to sort of look at us because they're thinking like, why haven't we done our 50%? They think this is the reason. They think it's because we don't want to. Not that actually we don't have this figured out in this particular kind of way, but they really do believe we don't want to. I was telling Ming last night that when Harvard was forming its Center for the Environment, and I was very excited. I was thinking, oh my gosh, we're going to get funding in architecture. Well, it turns out no, because, we know what we're doing. And I had an argument with John Holdren, who became the Deputy Secretary of the Department of Energy. And, in talking to him about it, and it's just like, no, actually, these are all the areas we could be researching in architecture. And his response is, you all, I was a part of you all know what you need to do. You choose not to do it. I said, I would like to know what I know to do because I don't know what to do is. And his response to that is, You just need to put more insulation in buildings. So that was his idea, for it. But anyway, there actually was a study done, interesting enough, for the one branch of the Department of Energy to still be repeating this number. There was a branch that actually not a branch, this is the National Research Council, that audited all of these programs on buildings. And this was, at the time, it was an audit done, you can see, from 1978 to 2000. And they had sort of pegged that $2 billion had been spent on this research. And this is what they found. Only 3 programs at that time period showed any kind of sort of energy reductions. Advanced refrigerators, you have to be a certain age in here to know how different refrigerators are today than they used to be. It used to be you could use them to heat your house. They were that inefficient, you could heat your house. I actually did it one time when my furnace went out. Electronic ballast, we don't even care about that anymore, but moving from magnetic ballast to electronic ballast and fluorescent lighting, game changer in terms of reducing energy. And then what we still use today, low emissivity glass. None of the other technologies or projects at that time that had been identified made any difference. Since then, we do know 2 more technologies that have matured and have well-developed effectiveness and penetration: variable speed fan drives in your environmental systems, solid state lighting. And probably sort of the next one that's going to be picking up will be heat pumps as they sort of continue to find wider penetration on that. And right now, I think the focus is primarily on smart grid integration. But, what was actually giving us results compared to the numbers they were sharing, there was a wild disconnect within that. So this is now the latest IPCC report that's out. They're now working on the 2027 report on this. And what's been very interesting within these reports, I don't know how many of you read these reports through the years, but I read the reports through the years. And, buildings were accounted for, but there was not a whole lot of discussion about buildings. There's a lot of discussion about buildings. And now there's also chapters dealing with urban systems within this as well. And so in the building chapters on this, they identify these main drivers of emissions: population growth, especially in developing countries, an increase in floor area per capita, inefficiency of newly constructed buildings in developing countries and low renovation rates in developed countries, increase in the use, number, and size of appliances and equipment, especially cooling. All of these are right. What's not so right in this report is what they think will resolve this. They believe that they've moved the number up to 85% from 50, that you just have to have policy, do some decarbonization of your sources, adopt technology, and do bioclimatic design, which they never discuss within the entire report, what actually that means. Another report in there says what you need to do for buildings, use best practices. So there's a big disconnect about who's come up with what you're actually going to do in order to address those kinds of problems. So let's walk through some of these. The first thing is, this is looking at the energy intensity of US commercial buildings in selected years. And you would look at this and say, wow, we're really good because our energy intensity has gone down. What energy intensity is energy per square foot or energy per square meter. That is a particularly poor metric to be using. And I'm going to explain to you why this is such a poor metric. The one thing about this metric is it looks better the bigger you make the building. The bigger you make the building, the more this number goes down. You're not saving energy, you're actually using more total energy, but your metrics look great. Yet this is our metric. This is the metric that everyone uses, which is energy per square foot or energy per square meter. Now the thing is, and this again, this jives with the IPCC report, buildings are becoming larger in square feet per capita and per function. And here's an important thing to sort of think about. Every single dimension increase, if I add a foot in this direction, I add an increase in the materials by the square of that foot. I increase ambient systems by the cube, which is kind of an astonishing number. And so the thing that's sort of really interesting in that is that the reason why I look better on this is that if I'm dealing with loads related to occupancy, which will often be all of the individual equipment someone has in the space, plus sort of like the need for certain kinds of lighting devoted to certain types of tasks, I am going to reduce a per square foot. I have a per square foot reduction in non-building determined loads. So the easiest way that you can make a building look like you're making huge progress, that it's way more efficient than anything else, is stick an atrium in it. If you stick an atrium, you're taking all the people out. You're taking the people out, you're taking their equipment out, you have lower lighting requirements. So your building looks fabulous on a per square foot, energy per square foot basis. You're not doing any good on an energy total basis in terms of the things that need to take place in that building. And so a lot of times when people are sort of like dealing with what's a sustainable action I can take in a building, they're using the wrong metric to sort of like pluck those things that they think are working. So total energy use still increases when you make your building larger, even though the energy intensity number starts looking better. And then if we think about this worldwide, we've slowed down a bit in this country in terms of, household size. Yes and no. So while the typical home in the US, we're not increasing as fast as we used to, we are dropping the number of people in it. So it's still creeping up, but by dropping the number of people, it means we're actually kind of going like this in terms of sort of how many people we're serving in terms of the energy use that we have. When we think worldwide in this, these space per capita rates are going up even faster. In the 1960s, the average living space per person in cities was 4 square meters. Mandates the 90s called for an increase to 20 square meters. This is in cities. By 2000, it was 26 meters. In 2020, it was 39.8 meters per person, which is a stunning increase. By the way, still way less than what we have in the US. I often spoke to parliamentary committees from both China and India about this very topic. And it used to cause a great deal of dissension within the talks because of my concern in terms of sort of our increasing space per capita. And they did feel, and by the way, rightfully so, I had no business bringing it up when here in this country, we were still way outpacing them within that. Yet this is where we're seeing some of our largest energy increases within this. And again, we're thinking about those sort of competing development environment curves. In Mumbai, India, the average living space per person is 9 square meters. Slum dwellers, it's 1 to 5. For the richest 10%, it's 26. And again, here's the average for the US is 93 within that. So we're vastly higher than anybody else. What's very interesting, and this is sort of where it kind of go in a slightly different direction on this, is that if we think about lighting standards, now we've become way more efficient in our lighting. I mean, what we can do with an LED versus if we start to think about, particularly things like arc lamps, back in the 19th century is absolutely stunning. But look at what happened to lighting standards. Now, I made this slide. I'm going to show the next few slides I made. You can tell when I made the slides in 2000 for students. So this is now 10,000 is daylight. It's what we'd get if we stepped outside, not looking at the sun, but daylight, like stunning. Now that number doesn't show up very often. But where these numbers show up, by the way, all of our numbers for lighting come from the lighting industry. They don't come from, again, the reason I invited the neurobiologist to come to my conference is this is someone who knew how the eye worked. They're not coming from neurobiology. They're not coming from any of that field. They are coming from the lighting industry. And so even with all of the attention and energy that we put in there, and again, you can get 500, you deal with 500 lux with today's lighting, it's still going to be less than the 10 lux that they were getting with what they were using back in 1910. But the thing is that when you're over 3 lux, that's your eye now has full photopic vision. So you can distinguish things at 3 lux. Once you hit 3 lux, everything is about contrast and comparisons that take place across the retina. So we see everything through contrast. That's our understanding how we define everything. We know this is here because there's a contrast in light level. That's how we understand that. That's how we see. But none of the way that we design lighting takes into account the way we actually see. We are still sort of like dealing with lighting standards and our idea about what we need to do with lighting, which is universal lighting that comes from over 100 years ago. And it beggars belief when we begin to think about neurobiologists can explain this to us. We can see this, we can witness this, and yet we still do this. So this was a slide that comes from that first time period, 2020. This is the library at Gunn Hall at Harvard. And I use this as an example for students is like, why in the library that no matter where you are in that library, it's exactly the same lighting. And I'll show another image of this in a second. Whereas already back then in cars, we're having a differentiation based on, guess what? How you actually see. What would make it best to see. And if you look at this today, this is Gunn Hall still today. This is now, another several sort of years after the other one being made. This previous image is from 2000. So this is now 25 years later. They have changed the desk. But not only do they have that lighting, it's floor to ceiling glazing. Right there. Now, granted, it's an overhang, but, and this is not even sort of an important room. This is actually where you check out books and all that. And there's couches to sit in and kind of lounge in. They've never changed that, and yet with cars, we're becoming more and more sophisticated, understanding how to get the best visibility out of the cars, but also really improve the visibility for the pedestrian and others without blinding them in terms of what they're seeing. We get that. They're working with people who know how you should see within that. And then what's really interesting to me about this particular approach is, again, this is something that comes from industry at the time. We ended up in this from the original direction. This is from the first arc lamps that came out and started going into manufacturing. They were so expensive, people weren't buying them. And so the way that they sold this to the public, and I actually have the old marketing documents from this time period, was to say that people were being damaged if the light level varied. They called it roller coaster lighting, and it was causing irreparable damage to your eye. And that was how they got people to start putting in more and more and more and more lighting. But we've just continued on this, and we've never stepped back on this. For me, when I talk particularly to architecture schools and to architecture students, you can make an incredible difference overnight in terms of just really rethinking the way that we light. Using it to sort of like really think about, what do I see? How do I work within that contrast ratio? Not only would you save an enormous amount of energy, but what you design when you're actually designing for how people see and how people experience, it's an incredible opportunity. And some of the most beautiful things you'll see out there are ones where this has been very thoughtfully done. And this one, I just love this example, and it's I know I'm probably segueing slightly off topic, except nothing sort of demonstrates how poorly we understand how things work than this example. Dietrich Neumann, professor at Brown University, pulled together a symposium on Richard Kelly. I hope everyone knows Richard Kelly. If you don't know Richard Kelly was a lighting designer from pretty much every sort of like 20th century masterpiece that was built in this country. He did all of Kahn's buildings, Lou Kahn's buildings. He did all of Mies van der Rohe's buildings. He did Saarinen's building. He did them all. So this so he pulled together this symposium, and one of the things that happened while he was working on it is that Richard Kelly's daughter found in her attic all of Richard Kelly's notes. And, and so Dietrich and I spent a couple of days pouring through those. And, what I was fascinated with in this is the way that it includes his sketches, which I'm going to show you in a second, but it includes the way that thought about here the Seagram's building in New York. Everything that's been written about the Seagram's building talks about how these planes, horizontal planes of light, were designed in order to sort of create a particular type of experience of these floating floors on that. You cannot read something written about the building that it doesn't talk about the way it was designed at light, designed for night. Except when you read the archival material, it turns out that's not why it was done like this. It was not designed for night, it was designed for daytime. And this is the brilliance of Richard Kelly. Richard Kelly realized that because Mies wanted floor-to-ceiling glazing, the room would be unbearably bright. You would have no contrast for your eye. The way he sort of, you'd have too much contrast for the eye, the brightness coming from the floor-to-ceiling glazing, and then being in that room meant that you'd have a hard time dealing with things because the contrast was so high. So he wanted to manage the contrast level. So this is his proposal, that next to the glazing, you had the most amount of light. You're next to the window, the curtain wall, that was a whole ceiling filled with light. The more you moved in to the building, the less light you had. It's exactly counterintuitive the way we think about it. We think we're in a darker area, we need more light. The opposite is true because, again, the eye is dealing with relative contrast, not absolutes on that. So the whole thing was designed in order to stage all the way in. And he makes it really clear that the idea was for that lighting to be on in the daytime, not for it to sort of like create an image at night, but to be in the daytime so people could easily transition from core of the building where it was darkest, to that particular area. And then this is showing that. You can see here now in an actual photograph how that light begins to stage as you get away from that. He was exactly right. That's exactly how the eye works. And actually, if you start looking at his work, you'll realize that. What's also very interesting, this is for a different time, a lot of the things that we assume about the way many of these buildings were light, when you begin to study Kelly and you start to see all the buildings that he worked on, you realize that almost everything that we've used as a precedent study about lighting, we've interpreted incorrectly. The way we think about the Kimball Museum and the vault lighting, no, it doesn't work that way. The way we think about the Menil in Houston absolutely does not work at all that way, even though I would say for 30 years, I saw students sort of like documenting it as if this is how it worked. Actually, it doesn't do that. But anyway, this is a side on this, but it shows that, yes, this was a lighting designer, in the 50s and 60s and the 70s who did understand how things work. Now, he wasn't trying to save energy, which is why he was, fully lighting those spaces on that, but he knew how the eye worked. He really knew how the eye worked on that, something we could learn. Thinking about conditioning spaces, there's been a lot of work by many people on trying to think like, how do I reduce the space that I'm conditioning? Vince James tried it in New Orleans with the Lavin Berwick Center. It didn't work so well. He identified this space would be fully conditioned and then we're going to stage the spaces from there. It was hard to do. Where he was really successful with this project in Beirut, where, began to sort of realize that with selective shading, with selective adjacencies, I can begin to sort of like reduce what I'm actually enclosing and start to have a lot of my space on the outside on this and not have it be conditioned at all. This is a project in Seattle that they only light where they're doing close work. And they realize they actually have plenty of light with no lighting turned on throughout this, except at certain moments. And it actually creates this sort of beautiful sense of a choreography of contrast as you go through. And this is a weird project that I worked with Scott Cohen. Scott approached me and said, I would love to take some of your ideas about, how you work with different kinds of thermally zoned spaces. And what he really wanted to do was have this space be a different temperature than this space, but have no walls between them. And I said, that I cannot do. But what I can do is help you stage them vertically. And so that ended up with sort of like these series of open cuts going up and down. And yes, it works. I would not want to be there in the wintertime. But yes, you can do that. You can create these sort of like different stage zones within. It's sort of a small example of just different ways we can start to think, do I have to have a big hermetic shell and everything be the same thing inside? Why can't we really begin to sort of think about these sort of like layers of experiences going through this? This is a metric that I started working on at Yale. We installed a lot of instrumentation in buildings. We had a fantastic way. I think people probably didn't appreciate this, but we actually could determine if they, plugged in their phone or turned on a coffee maker, we could track it to the person in the room. So we had to remove identifying data from a lot of this, but began to realize that rather than dealing with sort of energy per square foot, what if we started to look specifically at these particular areas, because we would treat them all differently. And the thing that we found that I think would catch a lot of people by surprise is the least significant thing on here was the envelope. Almost all of our strategies are about designing for the envelope. Now, I'm not talking about a house. We're talking, these are institutional buildings. So they're fairly robust within that category. But that was sort of the least efficient thing in there. Really, is that we could make a difference by coming back, almost countering what I said before, by working with the individual equipment efficiency. What we discovered is that the biggest area to work on was putting in variable speed fans within that. That was like a big ticket item for this. But this was sort of where we're beginning to work. I'd love to keep working with people and figuring out just sort of what would help us know what to I can know what to focus on. Number 3 is all about the way that we think and design. Number 2 is what we buy, and you're going to have sort of like different, you could imagine sort of like different pressures or different objectives or different subsidies depending upon where you are on this. So embodied energy, if you can think about it, we talk about it a lot, but embodied energy was not talked about very much at all. You can see this is from 2011. The Department of Energy was still telling us, who cares? It's not really important. Well, we know that it's important. And so important that just a few years later, when the IPCC put out its first time that it looked at urban areas within that, it sounded the alarm on embodied energy. And this is a scary alarm. Oops. I missed something on there. This is a scary alarm, that they estimated that if you truly looked at construction from an infrastructure standpoint, and what they mean by this is sort of like, yeah, you're going to put a building in, it also needs a sewer. It needs to connect to the sewer. You're going to put a building, it's going to need a road. All these things that you add for a building, when they were looking at construction, including the infrastructure on it, they estimated that by 2040, 40% of our carbon emissions are going to come from concrete used in construction. Again, something we're not at all ready to grapple with. We might be grappling with doing a mass timber building. We haven't grappled with all of the sort of consequences of the way that we build. So this is going to be something that's going to be controversial because it's going to go against everything that we believe in. This has to do with densifying. We believe that if we densify a city, we are going to have many good things come up. It'll be more sustainable. It'll be more affordable. It'll be more walkable. Those are all the things that we deeply believe. I had a PhD student at University of Texas in planning. The name was Stephen Richter. And anyway, I'll get to that just one second. again, that all comes from sort of this study done many, many years ago, looking at urban density and transport. You can see low density cities here, high density there. What we don't seem to come to grips with is that it didn't matter whether you're in Australia or Canada or the US, we're pretty much all in the same category. We're all countries that deal with massive spaces. And so we are going to have that kind of thing. And New York is not that much different than Houston, as much as we think about them as being wildly far apart. In this kind of sort of scenario, they're not that different. So Stephen came to me, and he really wanted to sort of like find ways to encourage people to densify their cities. And I told him what I tell all PhD students, that no good PhD is coming from somebody who wants to prove something. That if it's a good PhD, you're going to have to accept if it takes you in a different direction, and you have to allow it to take you, where the evidence takes you. Stephen studied 42 US cities that had densified, most of them due to directives, newer directives on that. In 41 of these cities, increasing density resulted in reduction in tree canopy, we'd expect that, increase in impervious surface, increase in per capita energy use, increase in income inequality, reduction in the use of public transportation. And the reason why is because it's not the idea of densifying that's bad, it's just how we're quick to do it. This is how we were quick to do it in Austin, which has been quick to do it. I'm fighting this right now in Savannah, but this is happening in many places, is that you're tearing down lowest income parts of the city and building 5/1s. So you're getting the density numbers that you want. The people who are buying the 5/1s, in this case in Austin, it's tech bros. And believe me, they're not walking anywhere. And they are definitely not taking the bus. And they all live individually in these particular units, and they have all the amenities you could possibly want. All these, by the way, have a pool too. This is what's being torn down. It has devastated the entire East Austin. I don't know how many people have been to Austin recently. East Austin has almost disappeared, with the exception of some of these bungalows have been saved for like boutique restaurants and clubs. But most of the residents have been chased out. So what's happened is that the lowest income people who lived in the parts that are being densified are being pushed beyond the boundaries. They can't live close enough to take public transportation. It stops out there. That's why public transportation use stops. That's why income inequality has gone up. And then we did an additional studies with our sustainable design students, found out that energy per capita is also much higher in these places. Interesting enough, a surprising number of people in Austin lived with like a single fan or a window unit. So they were using very, very little energy. So yes, from a density standpoint, all these little tiny single family houses did not look good in comparison to the density numbers you get here. But everything else about them made that a more sustainable city, the way it was, and a more equitable city. And you can tell where they are. This is life expectancy. It matches exactly where the low-income community was, and the low-income community that's been pushed out. The high-income community is everything to the west, which, by the way, is very undense. But believe me, they're not going to be building there. It's easier for them to take over multiple ways, take over the properties in the low-income areas, densify there, than it is for them to start to densify in the high-income areas. This is sort of another thing that's been happening there. 5 of these high rises went up in the time that I was living there, the tallest ones. This one under construction is their first super tall, and in Austin. And the principal of the firm that's building it said that it is, first of all, hey, it's great for density. So it's going to be, this is what we're doing in the name of sustainability. But even more so, that it's going to bring back an old-fashioned neighborliness to Austin. And when asked, well, how does that work? He says, the elevator rides will be so long, people are going to get to know each other. So this is where things like this get taken to the extreme. let me try to wrap up. Apologize. I'm so wordy. This happens to me all the time. We have grossly oversimplified rated of forcing to be about greenhouse gases, particularly carbon dioxide. It's about so much more than that. It's about every single thermal emission we make. It's about every single reflection that's out there. We pay attention to carbon because it's trapping what's trying to go back out to space. But if we create more of that to trap, we're exasperating the situation. And right now, we're creating a lot more to trap. Albedo, a lot more attention to it in the building industry. We got to pay a lot more attention to it than we have been. Thermal emissions, very difficult for us to quantify and attribute. But this is the scary one. This is the one people haven't talked about throughout much of this. We're only beginning to talk about this is water vapor. Water vapor is a much bigger greenhouse gas than carbon dioxide. We've never talked about it because supposedly was not man-made. Today's water vapor is man-made. It used to not be something man-made. It was just something we accepted. We have dramatically increased water vapor in our atmosphere, and that again through our actions on it. Let's see if I can be really quick on this. We've seen a lot of initiatives on cool roofs, trying to sort of like increase albedo. You increase albedo, you don't have to worry about greenhouse gases. You're doing your part there as much as you can. MIT is working on new pavement materials in order to make a difference. But again, a lot of work there and thinking about how we do this. Let me skip quickly through this. And come to this sort of like thermal emissions. We're doing all of our attention on, making electricity, particularly alternating current. The thing is that every single energy use creates thermal emissions. Every conversion is a thermal emission. And if you sort of like choose, you make decisions, poor decisions about what the source is, you're creating unnecessary thermal emissions that are, again, those things that are being trapped by greenhouse gases. And so if we kind of look at what's known as an exergy chart, alternating current, which is we're spending a whole lot of time trying to decarbonize alternating current, is the universal donor. We can use it for everything, and we do use it for everything. Each one of these is a downgrade. Within it, so it's downgrading. Direct current, really not good for rotational equipment, but fantastic for low voltage lighting, digital equipment on this. And this is sort of one of the things that's really frustrated me doing a lot of work, formerly having designed power plants in the past and dealing with it today. We have things like photovoltaics and fuel cells that make direct current. We have to bump it up to alternating current. So we pay a penalty to bump it up, and then we bump it back down to use it for low voltage lighting. This is a waste that we should not be doing. We've been talking now for about 20 years on DC microgrids, that as we begin to expand in different things, DC microgrids would make a world of difference in terms of better using any of these types of tech, but we're not doing that. We stay hyper-focused on alternating current. Geothermal systems, and I don't mean fancy geothermal systems, but, and I don't mean dealing with deep wells. I'm actually talking things that are sort of readily available near surface for us to use. We can certainly do some space cooling, some water heating, some space heating within it. Solar radiation is only good for heating stuff, but we tend to overheat with it or don't use it where we could be using it. Another place that really frustrates me is that no better way to have hot water than to have solar heated hot water. Like a match made in heaven. Old approaches to it done in the 60s and 70s were not the right approaches. It was sort of colored by that. If we start thinking about how we might be able to do that for a neighborhood, that started thinking about a scale other than a single house having to deal with it, we could get a lot done in terms of water heating. And then ground coupling, just sort of like even where even which sort of orientation you take advantage of to share radiation with. We could do so much. We just don't spend as much time thinking about the nice match, where energy wants to go, where it's most efficient. We spend all of our time trying to sort of like come up with stuff for alternating current. And guess what? In the field of architecture, we actually aren't very good, electrical engineers within that. It's not something we should be thinking that we could figure out on that. And here's our big problem, is that we might be trying to decarbonize our grid. We are adding more energy uses faster, way faster than we're decarbonizing our grid on this. The thermal emissions matter. I was a fellow at SUNY Buffalo some years ago, and I got to spend a full day walking through the building with the building's facilities manager. And it's something I do every place I go. I make sure I'm on the roof. I make sure I'm walking through the mechanical rooms. I meet with the facilities manager to understand things. And the facilities manager thought it was really strange that here they are in Buffalo, and they didn't have the heating on for an entire winter. And he'd heard a lecture of mine. He says, do you think it's because of all the equipment and lighting we have in here? I said, yes, it is because of all the equipment and lighting you have in here, and also your new windows that helped on this. But all of our electrical devices are heaters. But those aren't the worst part of this. The worst thing that we're dealing with, we are so unprepared. Believe me, I only have a few more slides. I'm really just about done. Is air conditioning. Here we're looking at the thermal emissions of roof condensers. Each of these, again, a tremendous amount of energy we're moving out of buildings. This sort of a chart looking at the incredible rise that we're going to have in both air conditioning units, and we haven't even come close to the penetration that we expect to have worldwide in terms of air conditioning. Air conditioning is particularly problematic. You're dealing with both a direct thermal emission, but you're also dealing with a water vapor emission. So here's the dilemma that we are, is that the amount, we're dealing with water vapor in two different ways on this. We are increasing the amount of water vapor that we're releasing simply due to the amount of air conditioning we're dealing with. But because of the feedback cycle between air temperature and moisture content, we're also sort of raising the amount that's evaporating from the earth. So we're seeing our humidity levels or our water vapor levels really pick up and really rise on this. I'm going to skip right past this one, because this is actually showing the temperature anomaly due to sort of like bringing in the water vapor into play. And so it's not just sort of like the heating that we're dealing with, it's the additional water vapor we're putting in the air and sort of like dealing with the thermal anomaly. This is in a very quick time period that we're picking up. Again, we haven't come close to dealing with this. My last slide, I'm really over. One of the things that kills me about that, because I teach climatic design, is that we do have, wonderful examples that we can look at where, really brilliant strategies for climate. This is one of my favorite ones on that. A lot of these don't work anymore. They're not practical anymore, particularly as we're increasing water vapor. The ability to sort of take advantage of night radiation, that's starting to disappear in many parts of the world within that. A lot of things that might have worked for this are no longer part of our palette on this. So if we could do anything, if I could leave you with one thought to do as sort of your charge, is that stop worrying about decarbonizing the grid. Actually, do encourage other people to work on that. Stop worrying about all those things. And I'm not even all for putting lots of attention to buying the most efficient equipment, but you should do anyway. Figure out how you can cut consumption. Think of every way that you can cut consumption. How do you eliminate in certain places the need for cooling? How do you eliminate the need for lighting or reduce the need for lighting? How do you eliminate the need for additional materials within that? Every place that you can conserve. Don't look for somebody else to sort of like take care of this for you. This is what you can do. And this is actually our first salvo in making a difference, is actually a radical reduction in energy. I'm really done at this point. Thank you so much. I can't believe you're born with me, please.
Thank you for a pretty amazing lecture and presentation. It's really introduced a lot of topics that are very fascinating and I haven't been very aware of. One of which was the solar heating for water that you mentioned, not only on, but then you basically doubled down on a neighborhood scale. I was very curious about what that sort of looks like in practice, if there is a form of it that has been explored or started to be researched, because I really can't conceptualize how that starts to form.
We're going to have to conceptualize that. We've certainly seen this in certain indigenous communities, so it does exist, but in terms of how we might modernize it, there's a company called Icon that does 3D concrete printing, and they're really right now focused on single family houses. And the one thing I've been talking to them about is like, how do we rethink this, to serve a community a different way? It doesn't have to be a house. And so one of the things was, how we might do cisterns, begin to think about where some of these types of cisterns might be located. And the other thing I've been talking to them about is maybe finding ways to selectively put shear walls throughout earthquake-prone communities. I think there's a lot of ways we can think about the way that we build, and it doesn't have to be always configured in terms of a building on that. But by the way, if you're interested in working on that, I would like to work on that one. So good question, and I'm sure there are people out there working on it, and I need to find out who they are.
Also just project. So again, thank you for coming. You mentioned a couple of times that there was various the synopsisms, like conferences, basically.
Symposium.
Symposiums.
They all have a synopsis with them, okay. So you're on track. You're good.
There were various symposiums that the one with like Brunswick, that was very successful, but then other ones were just less so. What makes for a successful bringing people together, and how do you recommend that we do that as well?
I think that's like the question in academia, in that one thing it actually, I was surprised for the Brundtland. Most of the Brundtland Commission part went, Brundtland Symposium went very well until the end, but sometimes a closed session where people aren't worried about making an impression, trying to win over an audience, try to sort of like establish themselves, or trying to get tenure, all those types of things that can come into play, but in small closed sessions. Although on the other hand, the one that I opened with was one that really went off the rails, the one that was supposed to be the summit on that. But those, to me, I had amazing conversations over the years when there's been a small group of us. Alcohol sometimes is involved, but mostly it's when you feel like no one's judging you, that you can allow yourself to speculate and be open. And by judging you, whether they're judging you performatively or judging you professionally, but it also means the people involved have to be willing to be wrong, really willing to be wrong, and in many ways embracing the fact that they maybe didn't know how things worked.
Can I speak with it? Can I speak with it?
It's better our viewers can.
First of all, I want to thank you for coming and for a marvelous lecture about topics that we don't normally or typically speak about in the school, or any school probably. And I want to ask you a very practical question, because we're pursuing models of design, both architectural and urban, that are either classical or vernacular, and that they are covering all kinds of countries and all kinds of places that are different than ours. How do we include the questions that you asked today and the issues that you brought up into a regular studio? Because I assume that another way to begin to think about this in depth and with substance is not when somebody comes to you 30 years into practice and say, what you're doing here, but really, in the first time you put a line on paper, this becomes an extraordinarily essential part of our lives and of our contributions to our lives as we become professional. How do we take these concerns and build them into architectural design at the daily studio level?
It's so difficult, and I will say that I struggled with this for so many years. The 25 years I spent teaching at Harvard and Yale before I became a dean was a daily struggle of figuring out how I was going to get this into studio. And I finally was able to get it to the students when I stopped trying to sort of like have it be a complete picture, that it stopped having to be a complete set of solutions. I started to split it up into, if they could understand one thing, what one thing do I want them to understand? And I will design something around that, and then they can take that understanding and then bring it into studio. So it wasn't about how to make their project better, but it was how to get them to understand one phenomenon. And I did it by teaching a class in light and materials, which is about as anti-sustainability as you can imagine, because it was all about sort of like smart materials. It was all about art projects. It was all about, actually making very extravagant things. But the students had to make multiples of each project, testing a different sort of like physics action, or working a different variable in each one. And by the time they were through sort of like trying to make something in 3 different ways that we were going to see in one particular way, they began to say, that's how the eye works, or this is the most strategic way, for me to do that. That was what I was most successful at. So I would love, I think I'm going to have to talk to Ming about this, but I would love to hear from other people who are struggling with this. But this is one of the reasons why we've talked a little bit about assembling, a brain trust, a small group of those of us who have been working on this for a long time, and beginning to say, when is the moment that for a student, for a practitioner, for a professor, they get that, this is how I make a difference in this. But because we want it to be strategies that we apply through our normative design process, we don't often go down those routes. So I don't think that's a clear answer. It's the best one I have tonight. So.
Thank you for this great lecture, and also